Greetings, my dear lecturer. First and foremost, I would like to introduce myself. I'm Dimaharan Prakash, TP080778. I'm here with my group members, Sharwin, Tushar, and Adam, to present our microcontroller assignment. So for this assignment, the topic we have chosen is Smart Voting System, a system which uses simple IoT components to do a smart voting in different polling systems. So let's talk about the components first. So we have used a LCD display. The main motherboard of the system is a ESP32. So we are using the ESP32 to connect all the 4 actuators. So how it works is with a small time frame. So as the first actuator gets verified, it gives a small time frame with 15 seconds for the second actuator to let the person in. So that's how the person can get in. And from there, the third actuator gets triggered only when the second actuator is turned on. So when the IR sensor lets the person in, the third actuator plays the role. And again, for the next person to enter and get verified, the second actuator has to let the person out of the room. So for the next person to get verified and go in. So this system and prototype was built in a systematic way for a smart voting system. So come closer. So let's talk about the prototype and the components. So here you can see a A608 fingerprint sensor. So this reads a person's verified fingerprint, and we use an RFID reader to read an allocated RFID card for the reader. The display to show a message for a welcome message or any other additional message for the person to tap in, and for the next person to wait when the room is occupied and stuff. So this is actuator 1 and 2, 3 and 4. So basically we connected actuator 4 and 1 with an 8-hour time lock. So only the actuator 4 can be accessed after 8 hours of the voting is being completed. And talking about the Firebase and the web application, we've developed a real-time web application to get all the information on through our Firebase to our application. So as you can see here, it's a simple Firebase with all the necessary information. Give me a minute. Okay, necessary information with the 4 actuators, and each actuator is given with a specific name. So actuator 1, we are going to name it as voter verification. So that is the process where the person is verified for the second actuator. So actuator 2 is being occupancy control. Basically it's talking about the room control. Actuator 3 is vote casting, for the person to cast his vote, and actuator 4 works as the vote vault, basically where the votes are being stored. So we are using Firebase to send our data through and get it through our web application. So this system brings us a compact smart voting system. So the first stage of our smart voting system is the voter verification. So as you can see, there's a LED display which displays a welcome message and says to tap in our card. So first, when we tap in our card, it will display our message saying hello and the specific person's name, and then it says to place the finger. So as you can see, so when the person is verified, there's a message saying the person is verified and he can enter to vote now. So after the verification message is displayed, it says thank you and you can proceed to vote, and the next person cannot override this with another RFID with another card or anything and say he's going to vote. The machine stops and displays a message saying the room is already occupied with the person. So this is how I connected my system with the next system, saying until the room is free, I cannot make a person to verify this. So let's say so these results can be displayed on our serial monitor. As you can see, the serial monitors displays everything. From there it goes to the Firebase. Firebase updates everything, and on real-time data you can see the person is verified, and it shows the seconds, how many seconds before the person has been verified and stuff. So now let's say the person has a different card. He uses another card to verify, which is not under his registered under his name or something. Let's test that as well. So when a non-registered card is tapped, you can see it displays a message saying the card isn't verified. You have to go to the admin and get your stage card verified or your fingerprint verified. So that that stage can be like processed with the admin. He can use an override and register his card. So once the verified card is tapped, and this is one of the important part, once the verified card is tapped, the person cannot again tap in this card for 8 hours. The card will be locked so that there will be less of duplications. And we have done 2 verification steps. So one is using the RFID card and the next one is using the fingerprint. So there will be less of duplications and voting will be simple and easy. So from here, I'll pass it on to my friend Adam.
Hi everyone, my name is Adam Bashir. My TP number is 074416. So today I'm going to present my part, which is home occupancy control system, which built an ASP32 microcontroller. So the system designed to automate secure access and real-time tracking of people entering or exiting the room. So the system used 2 IR sensors, 2 servo motors, and 2 is placed on the entry and the exit door, and 2 LED that's indicated. If it's green, that's mean the room it's ready to use. If it's red, that's mean it's someone inside it and it's occupied. So this is connected also to 12 volt power, and to step down to get 5 volt to power up the IR sensor and the servo motors. So after the person get verified from stage 1 and come to stage 2, the IR sensor detect the motion and open the door for him for 10 seconds. And also you can see it's updating, and it's updating on the web website. The group will count 1, the availability of the room is occupied. Let's come back here. So after the person finishes casting, so it's come to the exit door. The IR sensor also detect again and open the door for him for 10 seconds. Then only the room is updated again. The LED in green, that's mean it's ready to for the next person.
Hello everyone, my name is Tushar Rajesh Pillai and my TP number is TP072028. And today I'm going to talk about vote casting, which is my part. And as of you can see here, this is my part over here. The concept here is simple yet effective. When a person waves his hand over the IR sensor, a servo motor opens a compartment containing 2 voting buttons, one red and one blue. The voter then has a 10-second window to cast their vote by pressing one button. Once voted, the corresponding LED lights up to confirm the choice, and after the time window, the compartment automatically closes, ready for the next person to enter the room and cast his vote. This design ensures 1 vote per person per cycle, preventing duplicate voting while maintaining user-friendly interaction. Looking at the setup, you can see the key components: an ESP32 development board as the brain of the system, an IR proximity sensor for contactless hand detection, a servo motor that controls the compartment mechanism, 2 push buttons for red and blue voting options, 2 LEDs that provide visual feedback, and all connected through a breadboard for prototyping. This project could be adapted not only for voting but also other scenarios like classroom polling, customer feedback stations, and even museum exhibits. The modular code structure makes it easy to extend. You could add more buttons, connect to Wi-Fi for data logging, and integrate a display. And as a concluding, the vote casting system demonstrates practical embedded system designs combining hardware interfacing with robust software state management. As you can see here, this is the IR sensor is detecting my hand, and there are 2 parties over here, and I'm going to cast the vote for the blue party. So the vote has been detected. As you can see, the LED light is on in the blue party, and the gate has closed. And here my vote has been detected. The last vote is blue, and that's of my part, and I'll pass to the next person. Thank you.
Greetings, my name is Sarvin Mohan, TP number 077690, and today I'll be talking about the final actuator in our project, which is the vote wall. So, once the vote has been casted by a user, the thermal printer will print out a heat receipt, which will then be put into the ballot box. The ballot box, aka vote wall. So let's get closer to the vote wall so that I can talk about it. As you can see, this is the system. It comprises of the solenoid door lock, which is powered by a a 12V power supply. It has an RFID, a 5V relay, ESP32, a buzzer, and of course the breadboard. Okay, now let's talk about how this board vault works. So a chosen authorized person will walk up to the RFID, as you can see here, after 8 hours of the voting system being concluded. So now let's see. First, the person walks up to the RFID, it unlocks the solenoid door lock. Now as you can see, the buzzer is going off. Look here, it says locked, unlocked, and now the buzzer is on. So this is a fail-safe system where only one person with the same ID can unlock this system. So now I'm going to switch it off, and this switches off. It has to be the same card. As you can see, the UID over here, and if you see the serial monitor here, it says unlocked with the same ID, and the buzzer is off. Now let's move on to the next part. Now on to the next part, which is the part where I'm using an unauthorized card, which is a card with a different UID. So let's see what happens. So that sound from the buzzer shows that is not an authorized card, and if you can see through the serial monitor, it shows unauthorized card. So as you can see, this part of the prototype, the volt vault, has red lines over it, which shows that this is in a completely different place compared to the whole voting system, and this is to ensure security. So you can see no entry and the red lines. In conclusion, it's safe to say that our smart voting system is 100% success. All actuators proven by real-time data has shown that it works perfectly. We are also proud to say that this system can be used in multiple arenas. For example, in a factory or another company where you want to choose a new CEO or vice president, even a new cleaner, but it can be in a safe and fair way, so that everybody, the voters, get their votes right, and also the candidates participating in it have a fair showdown. That is also why we even created this in the first place, for a fair, smart way to vote. This reduces manpower, so that only a few manpower, for example, the guy that needs to authorize the RFID and some of the admins that can help out the voters in case anything goes wrong. So we didn't get a chance to talk in depth about our web application, which is, as you can see over here, the smart voting system web application. This is powered through the data from the Firebase, and as you can see, it comprises of multiple features. Firstly, it has the real-time graph of the red candidate and the blue candidate, and it even shows how many voters in real time. Then if you go down, it shows each stages and its relevant information. For example, in stage 1, it shows the status, whether it's verified, whether the user is verified, the update and the UID of that person's card. Stage 2 shows the occupancy control room, the people count, availability, and its last update. Stage 3 shows the vote casting system, where it shows the last vote, the state, and it's also the last time it's updated. And finally, stage 4, the vote vault, which shows whether the system is locked, the buzzer is on and off, and the last UID of the card used. This system refreshes every 10 seconds.